Hello. Today we are going to see how we can incorporate daylight features in the design builder model. First, to do that, we are going to build a two-zone building, 30 by 30 meters square building with two zones. Now we'll create another zone here. There you go. So now we have zone 1 and zone 2. Now to put the daylight design features in there, daylight for analysis, we have to go to activity panel and we have to check in the include zone in radiance daylight calculations. In my one it is already checked, but if it's not checked you have to check it in, and if you have that and checked in, then also you can take a look that what is the target luminance value you have in here, like 400 lux. You can go to different standard guides like ASHRAE or CIPC to find that what is the standard target luminance you can get here. So this is the generic office area, and for that we are going to put it for 400 lux. Then we have to go to openings, where you can see that you can change the glazing layout, and here we have 1.5 meter preferred height and 30% glazing wall to window to wall ratio, and we'll see that what is the result of this window to wall ratio in our internal gains later. Here we can see that the lighting level, we have to check the lighting control panel. But before we check in the lighting control panel, let's go and see that what we have in simulation without the daylight option first. We'll go for hourly also, and now we can see that because of the lighting, we have a constant energy fuel consumption here. If we go and change this to internal gains, you can have a better idea here. So you can see that the general lighting here, which is already checked in default, and it's almost like 210 kilowatt hour, and it's always constantly going in that area. So, and we have a solar gain in the exterior window, so there is a high solar radiation outside, and we can actually use that to our advantage by using daylight features. So we'll do that by incorporating the daylight feature. Let's see that how much we can reduce it. So we start that and we'll go to lighting control. Now when you turn on the lighting control, we have to see that there are different options here. We have a working panel height, is it the table height or which height you want in this room the occupants are going to work. So we put 0.08 meter here. Also we have a control type. There are three control types here. It's linear, linear off, and stepped. Linear off and stepped are in detail described in the help file. If you go and write lighting control you'll see that, sorry, yeah, yeah, there you go. So if you go to lighting control, and you will find there is the linear control. So a linear control means that when you have sufficient daylight outside, the interior lighting control will start to reduce the when with the amount of daylight increases so outside, but it will come to a point where minimal fractional limit, where it will maintain that minimum limit, but it will not stop it. Whereas if you go to linear off control, it will go to 0 when it doesn't need to be on. And in case of stepped, it goes down with the daylight luminance level. When the daylight luminance level increases, the fractional input power goes down stepwise, and you can control the steps you want to put here. So if you go for step, you can see that you can control the steps. If you go for linear off, you can just it will stop when there is sufficient daylight outside. And you can also control the glare. Maximum allowable glare index here is 22. You can the view angle or relative to in relation to y-axis is saying that at which angle the aperture is there when you are working, and that also contribute to the comfort level of glare and daylight, also the amount of light needed inside. So also you can see that we have percentage zone area, lighting area in lighting area 1. These features are basically saying that how many sensors you need in the space to work with. So here, if you choose one lighting area, if we go to the layout and go inside zone 1, see there is only one sensor. In zone 2 there is only one sensor, but in zone 1 it's situated in the middle. In zone 2, if it is situated in the middle, this area is not getting better sensor reading. So you can actually choose zone 2 and go to lighting, and you can put that you want another second area, and you can put target luminance level, let's say 400 as we described before, and then you can say that we need 40% covered by area 2 and 60% would be covered by in lighting area 1, 60% would be covered by the sensor. So now if we go to the layout, you'll see there are 2 now, and that is 1 and 2. Let's say that we'll select 2 and move it to somewhere here. Also we can select 1 and put it into a little middle position around somewhere here. You can also use the construction line to specify where you want to put. So now we have 2 areas there, sensors in that area. So now if we go to the lighting area again, we don't need the second lighting area here. We just need it in this zone 2, so we have it in zone 2, but in zone 1 we are working with one sensor only. So now if we in this situation, if we want to put if we want to see that how much the daylight actually affected our energy, if you go to the simulation, we'll see that. So the internal gains, here we are looking at the internal gains previously what we put to see the simulation results without the daylighting option. Now we are going to see that what happens when we incorporate the daylighting option on. It takes a little time because we put more calculations in the simulation now, and that's why it will come very quickly, but it's taking a little more time. There you go. So now you can see the general lighting demand, actually the energy consumption reduced with the increase in solar gain here for in the exterior windows. So basically with daylight we can reduce the amount of energy needed for lighting. We can see here. Also, if you want to see that how the lighting is distributed in the floor area, we can go to daylighting option, and here we have different options to look at. We can go for map, which is maps the entire room and or the total building. We can put it in grid options. There are different lead and BREEAM options. We can ask for the report. First we will go for map, and there is a detail template. You can include increase the accuracy level of the calculation by going to high quality or accurate. You can be in standard. Depending on that, your accuracy, if you increase the accuracy level or the calculation level, then it will increase the simulation time. And this is a working panel. We can put it 0.8. And margin means how far away from the edge of the room you want to calculate the daylight level. In the CIE over sky model, you can see that there are different sky model we can use. You can use any of them depending on the site you are choosing and the climate you are in. We are choosing for overcast day, and the luminance level you can change. We are putting it in 10,000 lux, and then you have the minimum grid. It's ranging from 0.05 to 0.2 in this case. And then if we can just put it okay, we would see that the map of on that work plane, it should come here. As you can see, the result shows that which area, how much lux you can get from the apertures, and also it also shows that the daylight factor, the percentage of daylight factor in this scale. Now we can see that most of the interior area, as it's a deep plan office, is not well lit, so you will need artificial lighting, and the level of acceptable range of lux is goes below 200 also. You can change the color of this. You can change like too dark color so that it's out of the scale, so you can see that it's below 200, these areas go black, and you can change with that. And you can also look at the building area, because depending on the total source, and here you can see that the whole range is there. We are not going anything below, or we're not giving it a user defined range. You're just looking at how much, so you can see it's below 10 lux areas are also there. If you are going for zone to zone, then it will show from one zone. If you can choose zone 1, if you choose zone 2, then so these are the separately shown data, as you can see. Also, you can calculate the energy consumption and how many hours you don't have sufficient lighting in the or you have less lighting in that interior. So to do that, you can go and export the energy plus output file, IDF file, and we can choose from January to December, and let's see. Okay, we'll create a file, daylight, and We want to open this file. Yes, we want to delete all the unnecessary outputs at the end so that it will be easy for us to see the result. Save it, and then we will go for Energy Plus. If we browse, we will go for daylight and simulate. Okay, so you're working with a London Gatwick weather file, and let's see what's the result. So there is no severe. Good news. Let's go to RDD file. Now if you search with luminance and exterior luminance, I don't need it, I need this one, daylight reference point luminance hourly in lux. And if I copy that into the text editor file, at the end just paste it and save it. There you go. Now we will simulate it again. Okay, now if we go enter in the variable tab, we'll see that we have two zones, and we have two zones, the lux level in that zones in that hour, and also we can see the amount of electricity and equipment, and also interior lighting is there. We didn't put interior lighting in there. So if we want to see that how many hours of lighting we are out of the lux level that we need in there, first we can do a filter, and we can just get rid of the out of hours, and then we can just create another light here saying number of hours efficient light. So we can create another cell with a number of hours insufficient light, and then we can write a simple function like if this level of lux is less than 400, or let's say 300, then we'd put 1, and if not, if it's more than that, it would be 0. So basically it is saying that which hours are basically out of the lux level or below the lux level, and if we select them, and you see there are some of the hours that we have sufficient light level, but some of them we don't. And if we go at the end, and just click sum from here to the top, so we can see that 2298 hours out of the working hours of whole year, the lighting level is not sufficient. And also you can you can create a relation with the amount of light you have and the amount of energy you need for this type of feature, and you can evaluate different design options to see that which design is giving you better lighting and better energy consumption. Thank you.